class 8. Last class, who can tell me what we discussed? Yes, it's about the magnets. And we all are familiar with the magnets and we know how it was discovered. Not only that, we know that a natural magnet is there. And what's the name of that magnet? Yes, it's the magnetite and it has got more iron content also, right? Yes. And we can classify the magnetic substances into two groups, magnetic materials and non-magnetic materials. Magnetic materials are substances that are attracted by the magnet. You know, materials made up of iron, cobalt and nickel. They all are magnetic materials. Materials that are not attracted by the magnet, they are known as non-magnetic materials, right? So many are there, plastic, paper, wood, etc. They all come under non-magnetic materials. And we know that different types of man-made magnets are there. Different types have different shapes of magnets are there. You know, bar magnet, first one. Bar magnet, next one. Horseshoe magnet. Next one, circular magnet. Third one, rod magnet. So there are four different types of magnets. Bar magnet, you all know, is the bar magnet. Okay. And horseshoe means what? Horseshoe magnet. Okay. Circular magnet. Circular magnet. And rod magnet, you could see like this one. This is the rod magnet. So these are different types of magnets and they can be available or they are available in different sizes and shapes. No, bar magnet shape is like the bar and this is the horseshoe magnet. This is the circular magnet and this is the rod magnet. So in different purposes we are using the magnet. For example, we are using the magnet in the televisions, refrigerators and for separating the iron objects from the waste materials or from the rag, waste. From all these things, for all these purposes, we are using the magnet. For separating big iron, iron gets rust very easily. So it is difficult for the people to touch the iron with the bare hand because they may get what, tetanus infection. So to avoid that, we are supposed to, they are using what big magnets to separate the iron materials from the waste. So likewise now for depending upon the use, the size of magnet and the shape of magnets what we are using also changes. So for that, four different types of magnets are there. What are they? Bar magnet, horseshoe, repeat, horseshoe magnet, then circular magnet, last one it is a rod magnet. Clear? Yes. So just observe this magnet, bar magnet. It has got two sides are there for the, and here also you can observe two sides. When you observe bar magnet and the horseshoe magnet, you could observe two sides are there, right? Yes. So when we hold the iron filings or iron particles or safety pins, etc., when we hold it near there, we could easily observe that they will stuck to these two areas faster. It doesn't mean that it doesn't stuck here. Of course, it stucks here also, but more amount or more numbers of iron filings or the pin, safety pin, they all can stuck to these two sides more. Two sides more. And these two sides are known as the poles of the magnet. What is that? These two sides are known as the poles of the magnet. Clear? These two sides are known as the poles of the magnet. And these poles of the magnet has got most attractive power. All the part of the magnet can attract the iron objects or cobalt objects or nickel objects. But these two sides or the poles of the magnet, they have the most attractive power. They can attract more objects towards them. Clear? So at the end of this class, you can watch a small video after watching that, you will understand it better, because I don't have now bar magnet to show you now how it attracts. So here, just understand it. When you watch the video, it will be more clear. Okay, children? So these two are the poles of the magnet, and the poles of the magnet, they have the most attractive power, so they can attract the objects towards it very easily. Clear? Yes. In case of horseshoe magnet also, we can easily identify the poles. Here also we can identify the poles. Clear? Okay. So, and when we observe the magnet, as I told you, it has got two poles, north pole and the south pole. What are they? Two poles of the magnet, north pole and the south pole. Hope you all know it. North pole and the south pole. And the magnetic power always travels from north pole to south pole. Magnetic power always travels from where to where? North pole to south pole. Clear? So these are the two sides of a magnet, and that is the north pole and the south pole, and these two poles, they have the most attractive power to attract the objects towards it. Clear? Yes. So one side is the north pole and another side is the south pole. When we suspend means what? Like this, when we hold this magnet and you can tie into a string, when we hold the bar magnet and when we just whirl it, whatever we do, finally this magnet will rest in a single position. You know what is that position? It always rests in north-south direction. Wherever we stand, whatever we do to that magnet, you can whirl it, swing, whatever we do, when it is at rest, what happened? It always rests in which direction? North-south direction. It always gets rest in north-south direction. Clear? Yes. Such a property of the magnet, it is known as directive property. The property of a magnet to remain in the north-south direction, such property of the magnet is known as what? Directive property of a magnet. Clear? What is the directive property of a magnet? The ability of the magnet to remain in the north-south direction. North means what? It points towards the north part of the earth. North pole of the earth. In SS you have studied about North Pole and the South Pole. Hope you remember that. Yes, the coldest area, polar region. Do you remember in science also? Polar region, extremely cold, North Pole and South Pole. And of course, east and four directions we all know: north, south, east and west. So this magnet, especially the bar magnet, always point towards the north-south direction. The part that point towards the north, that's the north part of the earth. The part that point towards the south, it is known as the south part of the earth. Geographical south and geographical north we say. Geographical means earth in the north side or earth in the south side. Clear? So by observing the magnet, you could understand which side is the north side and which side is the south. Clear? Yes. So, and why is it so? Many of you have that doubt in your mind. Why the magnet always rests in north-south direction? Some reason should be there, isn't it? Otherwise, no, it doesn't happen. It can remain in any direction. Once we hold it, it can rest in north-south direction. Second time, it can rest in east-west direction. Why isn't so? Why it always rests in north-south direction? Just think about it. Before going to the answer of that question, I want to let you know another important point about the magnet. You know the magnet, I have the circular magnet with me. See, I have the circular magnet. Clear? These two magnets I have. See, this is the pole. You know, this part is the pole of the magnet. In the case of circular magnet, this round area, it is the pole. So, south pole is there as well as the north pole. Both sides. One is the south and one is the north. Just see this. So, just look carefully. This I am Oh yes, bringing close these two magnets. Just see what happened. Yes, yes. Hope you could understand what's happening here. Can it touch each or can they touch each other? I'm just trying my level best to do it. Just observe it. Hope it is clear. Yes, I'm just easy holding these two magnets. Yes. Then just this, I'm just turning the side, opposite side. Just see what happened. Yes. I want to handle it carefully. Otherwise, no, if my finger touches here, no, it gets what into it. So see, I'm just closing it very carefully. Just see it. Yes. From this, you could understand that one rule is there for the magnet to get attract each other. That means you know how many poles are there for the magnet? Yes. How many are there? Tell me. Yes, North Pole and the South Pole. And just imagine this is the North Pole. And this is the, if these both are North Pole, they will not attract. If I just close also, it gets separated. That means two North Poles. Here, these two poles are the North. They will not attract. If I try very hard also, see, if I want to make it close, yes, they get separated. But one is the North Pole, one side is the South Pole. Just see what will happen. Yes, very easily they touches each other. From this word, you understand. Like poles of the magnet, repel each other. Like poles of the magnet, repel. You know what is meant by repel? No attraction. Vittu pova. Like poles means what? Both North Pole. Just observe, if these two, you see, these two are the same pole. That's the reason why I know they are not attracting each other. Yes, they are repelling. But unlike poles, you know what is unlike? Both should be different. Unlike poles, attract each other. Unlike poles, attract each other. Unlike poles means what? One north and one south. See here, these both are, I think, this we can easily check which pole is what. These two are the same. That's the reason why I know they are not attracting. And as two poles, what happened? See, nice. Very fast they get attracted. So like poles means what? Both pole should be north or south. Then they will not attract, they will repel. Vittu povane nokkatullu. It doesn't come to attract. But like unlike poles means what? One should be North Pole, another should be South Pole, that they get attracted. Hope it is clear. Yes, very, very important rule about the magnet. Like poles of the magnet repel each other. Unlike poles of the magnet attract each other. Like poles means what? Both should be same. Both North Pole or both South Pole. Unlike means what? One North Pole and one South Pole. They will not attract. They will attract each other. If both are same, yes, repel only. Clear? Yes. So this is another important, property of the magnet. First, we already discussed the directive property of the magnet. What is directive property of the magnet? The ability of the magnet to remain in north-south direction. And not the part that pointing towards the north, it is the north side of the earth, and the part that point towards the south, it is the southern side of the earth. Clear? Then now we are coming to the reason of it. Why? The magnet, always when we suspend a magnet, it always rests in which direction? North-south direction. Don't you want to know the reason? Yes. I know many of you want to know. Earth itself is a huge magnet. Yes, that's very true. Earth is a magnet. This example, this is the Earth. This example. You know, a magnet is having the north and the south. Agree? Yes. The earth, as I told you, earth is a magnet. So earth is having two sides or two poles. What are they? North pole and the south pole. Clear this much? Yes. Yes. When I hold, so here this is the magnetic north. This is the magnetic north. Earth ne oru magnet aayittu consider cheyyumbam, as I told you, earth is a huge magnet. ഏത് മാഗ്നറ്റ് നോക്കിയാലും we know that that magnet is having a north pole and the south pole. Clear? അത് ഏത് മാഗ്നറ്റോ ആവട്ടെ, എർത്ത് മാഗ്നറ്റ് പറയുമ്പോൾ ഡെഫിനറ്റ്ലി ഇറ്റ് ഓൾസോ ഹാസ് ടു ഒരു നോർത്ത് പോൾ ഉണ്ട്, സൗത്ത് പോൾ ഉണ്ട്. അത് എർത്തിന്റെ ആണ്. പക്ഷെ എർത്തിന്റെ നോർത്ത് പോൾ എന്ന് പറയുമ്പോൾ ആക്ച്വലി ആ ഭാഗം സൗത്ത് ആണ്. ജോഗ്രഫിക്കലി മാഗ്നറ്റിക് നോർത്ത് ആണെങ്കിലും മാഗ്നറ്റ് വഴിക്ക് നോക്കുകയാണെങ്കിൽ നമ്മൾ മാഗ്നറ്റ് എർത്തിനെ മാഗ്നറ്റ് ആയിട്ട് കൺസിഡർ ചെയ്തിട്ട് നമ്മൾ അതിന്റെ പോൾസ് നോക്കുകയാണെങ്കിൽ അത് ഒരു സൈഡ് നോർത്തും ഒരു സൈഡ് സൗത്തും ആണ്. ബട്ട് റിയാലിറ്റി അത് ശരിക്കും നമ്മൾ ജോഗ്രഫിക്കൽ, അതായത് നമ്മൾ ആ സ്ഥലം ഏത് ഭാഗാന്ന് പറയുമ്പോൾ അത് നമ്മൾ ഏത് ഭാഗം എന്നാ പറയാ, മാഗ്നറ്റിക് നോർത്ത് ആണെങ്കിൽ കറക്റ്റഡ് അത് എന്ത് ഭാഗമാണ്, സൗത്ത് പോൾ ആണ്. മാഗ്നറ്റിക് സൗത്ത് ആണെങ്കിലോ അത് എന്ത് പോളായിരിക്കും, നോർത്ത് പോൾ ആണ്. Hope it is clear. Earth we want to consider it as a magnet. As we know, magnet has got two poles, north pole and the south pole. അപ്പം ആക്ച്വലി എർത്തിന്റെ നോർത്ത് പോൾ എന്ന് പറയുന്നത് കറക്റ്റ് ആയിട്ട് നമ്മളുടെ സ്ഥലം വെച്ച് നോക്കുകയാണെങ്കിൽ അത് സൗത്ത് ആണ്, സൗത്ത് പോൾ ആണ്. ആക്ച്വലി മാഗ്നറ്റിക് നോർത്ത് പോൾ ആണ്. മാഗ്നറ്റ് ആയിട്ട് എർത്തിനെ നമ്മൾ കൺസിഡർ ചെയ്യുമ്പോൾ അത് നോർത്ത് പോൾ ആണ്. പക്ഷെ നമ്മൾ ജോഗ്രഫിക്കലായിട്ട് നമ്മളുടെ ഭൂമിയെ നമ്മൾ അതിന് പോയിന്റ് കാണുമ്പോൾ അത് എന്താണ്, മാഗ്നറ്റിക് നോർത്ത് ആണെങ്കിൽ ജോഗ്രഫിക്കലി സൗത്ത് ആണ്. അതുപോലെ ഇത് മാഗ്നറ്റിക് സൗത്ത് ആണെങ്കിൽ ജോഗ്രഫിക്കൽ എന്താണ്, നോർത്ത് ആണ്. സോ വെൻ വി ഹോൾഡ് ദ മാഗ്നെറ്റ്, bar magnet, they always suspend in which direction, north south direction. North south direction ആണ്. അപ്പൊ നമുക്ക് ഇങ്ങനെ കൺസിഡർ ചെയ്യാം. You can just do it once again. നമുക്ക് ഇങ്ങനെ കൊടുക്കാം. എർത്തിന്റെ ഒന്ന് സൗത്തും നോർത്ത് ആണ്, മാഗ്നറ്റിക് ആണ്, മാഗ്നറ്റിക് ആണ്. ദെൻ ജോഗ്രഫിക്കൽ എന്താണ്, ജസ്റ്റ് ഓപ്പോസിറ്റ് ആണ്, നോർത്തും സൗത്തും. അപ്പം ഇവിടെ സൗത്ത് ആണ്. മാഗ്നറ്റ് വെച്ച് കൺസിഡർ ചെയ്യുമ്പോൾ എർത്തിന്റെ സൗത്ത് ഭാഗമാണ്. അപ്പൊ ഇവിടെ ഏത് ഭാഗമായിരിക്കണം അട്രാക്ട് ചെയ്യേണ്ടത്, നോർത്ത് ഭാഗം. ഇവിടെ എന്തായിരിക്കണം, സൗത്ത് ആണ്. രണ്ടും സെയിം ആണെങ്കിൽ ഇത് രണ്ടുമാണ് മാഗ്നറ്റ്സ്. ഇത് മാഗ്നറ്റ് അല്ല, ഇത് എർത്തിന്റെ ജോഗ്രഫിക്കൽ ഏരിയ ആണ്. ഈ രണ്ടുമാണ് നമ്മൾ മാഗ്നറ്റ് ആയിട്ട് കൺസിഡർ ചെയ്യുന്നത്. അപ്പൊ ആസ് വി ഓൾറെഡി ഡിസ്കസ്, ലൈക്ക് പോൾസ് repel each other, unlike poles attract each other. So when we hold the bar magnet, അത് ഞാൻ പറഞ്ഞു അത് ഏത് ഡയറക്ഷനാണ് സ്റ്റോപ്പ് ചെയ്യുന്നത്, നോർത്ത് സൗത്തിൽ. എന്തുകൊണ്ടാണ് നോർത്ത് എന്ന് പറയുമ്പോൾ, ആക്ച്വലി നോർത്ത് എന്ന് പറയുമ്പോൾ നമുക്ക് ആ നോർത്ത് ഭാഗമെന്ന് മനസ്സിലാക്കാം. അവിടെ ആക്ച്വലി എന്താണ്, അത് മാഗ്നറ്റിക് സൗത്ത് ഭാഗമാണ്. മാഗ്നറ്റിക് സൗത്ത് പോൾ ആയതുകൊണ്ടാണ് ഇവിടെ രണ്ടും കൂടെ അട്രാക്ഷൻ വരുന്നത്. ഒന്ന് സൗത്തും ഒന്ന് നോർത്ത് ആണ്. പക്ഷെ സൗത്ത് എന്ന് പറയുമ്പോൾ ആക്ച്വലി അത് ഏത് ഭാഗമാണ് ഭൂമിയുടെ, നോർത്ത് ആണ്, നോർത്ത് പോളാണ്. അതുപോലെ ഇവിടെ നോർത്ത്, മാഗ്നറ്റിക് നോർത്ത് എന്ന് പറയുമ്പോൾ ഇവിടെ ആക്ച്വലി ഏത് ഏരിയ ആണത്, സൗത്ത് പോളാണ്. സോ ഹിയർ നമ്മളുടെ മാഗ്നറ്റിന്റെ സൗത്ത് പോളും അട്രാക്ട് ചെയ്യുന്നു. രണ്ടും അൺലൈക്ക് പോൾസ് അട്രാക്ട് ഈച്ച് അതർ. ഒരിക്കലും ഇതിവിടെ സൗത്ത് ആണെങ്കിൽ ഇവിടെ ഒരിക്കലും സൗത്ത് വരാൻ പറ്റില്ല, അങ്ങനെ അട്രാക്ഷൻ വരത്തില്ല. അതുകൊണ്ടാണ് നമ്മൾ എപ്പോഴും ഒരു മാഗ്നറ്റ് നമ്മൾ ഹോൾഡ് ചെയ്യുമ്പോൾ, എസ്പെഷ്യലി ഇഫ് ഇറ്റ്സ് എ ബാർ മാഗ്നറ്റ്, ഇറ്റ് ഓൾവേസ് റെസ്റ്റ് ഇൻ വിച്ച് ഡയറക്ഷൻ, നോർത്ത് സൗത്ത്. ബിക്കോസ് Earth is a giant magnet. Earth is a giant magnet having two poles, north pole and the south pole. So if the part that the geographical north, that area is the magnetic south. Geographical south, that area is the magnetic north. Isn't it? So it is because of that they get attracted towards each other. Clear? And hope you all have heard about the compass. You know the sailors. You know the people who are traveling in the ship. You know when they are traveling, they need to travel 4 months, sometimes years. That time, no, they cannot understand the direction. They don't know which direction is north or which direction is south. In such situation, they use the compass. In the compass, a needle is there, magnetic needle. In the compass, a magnetic needle is there. So needle always rest in which direction? North, south. So by using the needle, the sailors can easily find out which direction they are supposed to move. North, south, and of course, east and west. Very easily they can find it. Clear? Once we know north and south, very easily, east and west. So, similarly, the sailors, no one is there to direct them to go this way, to go that way. So, this is the only method used by them to find out the way to travel across the sea. They use the compass. Compass has got the needle to point, always point in which direction? Tell me. Yes, north, south direction. So very easily they can find out which direction they are supposed to move. Clear? Yes. So these are the most important feature of the magnet. What are things we have discussed today? Magnets, different types of magnets are there. What are they? Bar magnet, horseshoe magnet, circular magnet, and what? Road magnet. And we know that when magnets has got two poles, like north pole and the south, and the magnetic attraction is more where both sides or the both poles have got the most attractive capacity. Then when we hold a magnet, it always suspend a bar magnet, it always rests in which direction? North south direction. North side point towards the north, geographical north, and south side point towards the geographical south. That property of the magnet is known as what? Directive property of the magnet. Then we discussed about the attraction and the repulsion. Attraction means what? You know, coming close. Repulsion means what? Going further. Then what is attraction? Yes, like poles. If two north poles come close to each other, will they attract? They will be repelled. If one like north and one south, they will attract. So that's it. So that is the reason why the bar magnet, when we suspend it, it always rests in north-south direction. Because Earth itself is a giant magnet having two poles, south pole and the north pole. And the Earth, magnetic south actually is the geographical north. Magnetic north actually is the geographical south. What happened? Yes, so when we hold the magnet, north attract towards the south. Yes, south attract towards the north. So then if attraction takes place, then north part of the magnet point towards the northern area, south part of the magnet attract towards the southern area. Clear? Okay, children. Next class we can continue. So as I used to say every time, read the textbook thoroughly, do the exercises by yourself. So next class we can discuss the answers. Until then, be safe. Please don't, nowadays new virus, you have all heard that new virus is coming. Let's just reach here. And vaccination, of course, vaccination is there, but it won't be available for us now at present. At present it is giving to, the aged people and the, medical workers and all, doctors, nurses, attendants, those who are, related to the, profession, medical profession only. First the vaccine they give to them, afterwards the old people, then only we will get it. So please be safe, because after the corona also we want to be, next year we want to meet directly, not through the the Google Meet, not through the the online classes. We want to have an interaction, right? Yes. So that time now we all should be healthy. Am I right, children? Yes. You all should be healthy. Now we should be thankful to God that many have got that, and many are just also getting, but we are safe now, safe in the hands of God. So always pray God that we should be safe, and pray for others also. Okay, children? So until we meet in the next class, it's bye from me. Take care.
Now, see this? Every magnet has both a north and a south pole. The magnetic force in a magnet flows from the north pole to the south pole, and it creates a magnetic field around a magnet. If you try to push the south poles together, they repel each other. Two north poles also repel each other. That means like poles repel. Turn one magnet around and the North and the South poles are attracted to each other. Unlike poles attract. All objects are not attracted to magnets. Plastic, rubber, water, glass are non-magnetic materials. That means objects made up of these materials are not attracted toward a magnet. Objects like nails, screws, rods, etc. are magnetic. See, this is magnetic. It can attract the nails because they are rich in iron, cobalt, and nickel, which are strongly attracted to magnets. Scientists call these metallic elements ferromagnetic because of this strong attraction. The Earth is like one massive magnet. The Earth's core is a mix of iron and nickel, which gives the Earth its very own magnetic field. Magnets are very useful. They are used to make a tight seal on the doors to refrigerators. Magnets are used to store data in computers. They power speakers in stereos, earphones, etc. Now, you know a lot about magnets.